Okay, class, good afternoon to Alpha. Can you hear me?
Yes.
Everybody? Okay, thank you for your response. Okay, how about your internet connection for today? I hope normal lah, because early this morning lah, internet connection lah, Google Meet is very slow. But I think now is good lah, I hope you can hear my voice clearly, and then I'm able to record the meeting. And then now I try to share my screen. Make sure you're able to see my screen sharing. Right now I'm supposed to be sharing the screen right now. Can you see it?
Can.
Can also, okay, yes. All right. Some people are paused. There are message coming out. Some people are paused because there is an error in your network. What happened? Okay, never mind. Right. Yesterday, before we start, I gave you some very short exercise for you to answer on your exercise book. Okay, because yesterday we did not have any online classes, so I give you the what we call extra exercise lah for you to do in your workbook. So do you have any question about this? It is about level. Okay, we stop at level in 8 point in topic 8, chapter 8. Right? Do you have any question about this? Very easy, right?
Yeah.
Okay, never mind. So later on, I will give you the answer lah for the extra exercise that you already done yesterday. All right. So today we just continue the next topic for today. You can also open your textbook, page 183. All right. In 8.2, actually this is 8.2. Yeah, if you look at your textbook 8.2, in chapter 8, force and motion, is kind of what we call a bit long topic. Yeah, if I can write for you here, if I can write what are you going to learn, 8.2, right? All right, 8.2. The title for subtopic 8.2 is the effects of force. Effects of force. Okay, and then number 1, you learn about the effects of force. Effects of force. Okay, how many effects? There are, if I'm not mistaken, there are 6 effects of force. Okay, one of it is it can change direction. Okay, you can refer to the textbook. If you want to look at the effect of force, you can refer back to your textbook. Change direction, and then what else? Change what? Anybody can remember what are the effects of force? Number 1 in 8.2, change speed.
Shape.
Okay, and then change shape. And then what else? I think there is 5 or 6 effects of force. Number 1, if you still remember. Right. Number 2,
Stop.
we learn about what we call by buoyant force. Buoyant force. Still remember buoyant force? Right? Okay. Buoyant force. And then what are what we call the density, the relationship between density and buoyant force. Okay, buoyant force. Make sure you understand this. Right. Number 3, our previous lesson we learned about the level. Okay. So you must identify what we call the parts of level. Okay, and then the meaning of level, the definition of level. Okay, and then the classes, or what we call classification of level. Okay, parts of level. If I can draw the level here, for example, I have a level here. All right, consists of 3. That is, one is F, one is L, and one is E. E is for effort, L is for the load, and then E for the effort. All right. And then the classification of level, do you still remember? Class. There are 3 classes of level: class 1, class 2, class 3. And then depend on the center or the middle parts of the level. Okay. Depending the parts at the center of the level, determining the classes of level. Okay, for example, class 1 at the middle. Okay, at the middle. For class 1, class 2, and class 3, right? There are 3 types of classes of level. Class 1 at the middle, F. Class 2 at the middle, L. And then class 3 in the middle is E. Alright, so what are the classification of a device or the tool that have class 1? Class 1 meaning that the load and the fulcrum, the fulcrum is between load and effort. This is for the first class level. For second class level, you can say what are the definition, meaning that the load for second class level, the load is between fulcrum and effort. Okay, and then for third class level, you can say that the effort is between load and fulcrum. So this is the classes of level. And then also you must try to identify the tool or the device that use either class 1, class 2, or class 3 type of level, classification of level. All right. I give you the exercise yesterday, right? For example, this one. Okay. If you can see this, for example, this one. Right. Number 1, A. When I using the knife. So using the knife, what is number 1 lah? Number 1 is what? Number 2 is what? And then number 3 is what? Okay, 1 Roman. FLOE. Fulcrum, load, or E for number 1 here. What do you think is this? The holding the knife. Yes. Number 1. FLOE. Again, I can't hear you. Please speak louder.
E.
E, right? Okay. So
E,
number 1 is E. Right? Effort meaning that we apply the force lah. We apply the force. Number 1 is E. I think the sound is lagging, buffering a bit. Never mind. Right? Okay, number 2. Number 2. What is number 2, class?
L.
F or L?
L.
Okay, very good. Mamantai, good. Okay, I think you can, if you You can also type the message. Okay, this is L. This is the load. And then, of course, the last one is F. Okay, this is the fulcrum. Fulcrum is a pivot point. It's a point. When you are cutting onion, for example, this part at the fulcrum is stay at a fixed point. The only things you move is the end of the knife over here, for example. You will go up and down, right? And then this one, usually fulcrum do not. Fulcrum is usually what we call also a pivot. Pivot, meaning that it will stay there at a fixed point. Pivot. Okay, right. So very easy lah. Make sure you understand the device and the tool, and then understand which one is effort, load, and fulcrum. Okay. Last one. I just take another one example over here. Okay. B. Cangkul ini. Hoe. H-O-E. Hoe ini cangkul. So which one is F-L-E? Okay. A, B, O, C. A is what here? Over here, class? Cangkul. Yes, again. Repeat again.
F.
This is F. Very good. B? E. Okay, very good. And then C is? Of course, last one is L. This is load. All right. Then the classification of the tool, for example. You can see over here, L in the middle for the cangkul, for the hoe over here, E in the middle. So L is which class? For pisau. For knife, which class of lever? First, second, or third class? L?
Second.
This one is second class. So you can write here lah, knife. Just remember here, F, L, E. First class, second class, third class. And then FLE over here is at the center or at the middle. Right. Okay. And then for hoe, you can see effort in the middle. So which class is it? E? Sorry, for the cangkul here, for the hoe. Which one? The classes of lever here. Second, third, or first class? Effort in the middle. Effort in the middle. Meaning that it has effort in the middle. Third class. Effort in the middle is the third class. So you write here HOE for third class tool. All right. Plier over here. Plier over here, very easy lah. This is effort. This is L, and then this is E. F. This is F. And then at the middle is fulcrum. So this is the first class plier. Lagging, Wait, slow a bit, right? Never mind. I no need to give you the answer lah. I already give you the answer. Okay, very simple. What we call a simple exercise. I gave you yesterday, right? Okay, so can we continue? Okay, and then today we go to the next topic. We call it the moment of force. Okay, moment of force. Okay, moment of force in lever. Okay. So what is the moment of force? Okay, I will read it for you. A moment of force, a force acting on an object can rotate the object at a fixed point. Okay, and then the turning effects produced is what we call the moment of force. Okay, the turning effects produce. Turning effects meaning that 360 degree lah, you spin the, what we call, you can turn the object. That is what we call the moment of force. Okay, class. For example, I give you the picture over here. Can you see the animation? I don't know whether you can see the animation or not. A bit slow today, internet. Okay, can you see the animation? Can, very slow internet, Okay, never mind. Okay, moment of force, All right. Where is it? The moment of force. Moment, M-O-M-E-N-T, of force. Moment of force. Okay? Meaning that a force acting an object can rotate the object. So in this animation, which part is the object? What is the object? Is it the plier? We call it wrench here. This is the wrench. Okay, the red tool here. This is what we call a wrench. This one. This is wrench. And then we have a bolt over here. This is what we call a bolt. So, which are the two? The wrench or the bolt? The tool is wrench. The what we call the animation here. The person holding the wrench. Okay, wrench is the tool. Wrench is the tool, and then bolt is the object. Okay, when you apply force to the wrench, for here, the person over here will apply the force downward. You can see it will apply the force downward. Apply the force, or it apply the effort. Okay? It will apply the force and then apply the effort. And then what happened to the bolt over here? This is the object. This is the bolt or the object. Bolt or the object over here. What happened to the bolt? When the person apply the force, the bolt will rotate. It will rotate. Dia akan berpusing. Okay, according to the direction lah, whether it is clockwise or anti-clockwise. So, in the animation in front of you, the bolt or the object is rotating clockwise or anti-clockwise. Whether the rotate maknanya berpusing ya. Rotate either clockwise or anti-clockwise.
Anti.
Right now it's anti or clockwise? Yes, again?
Anti.
Anti-clockwise, very good. Okay, the bolt over here is turning anti-clockwise. So this is what we call by the moment of force. Okay, this is what we call the moment of force. Again, what are the definition according to the textbook? Force acting on an object can rotate the object at a fixed point. Which one is the fixed point over here? I will try to use the green. This is the fixed point. The green one is the fixed point. Fixed point. can rotate the object at a fixed point. We call it pivot or fulcrum, and then the turning effects produced. The turning effects produced is called the moment of force. Yeah, the turning effects when the object or the boat here turn, we call it the moment of force. Okay, is it okay, class? This is what we call the moment of force. Okay. All right. So, why the moment of force is important? Because the moment of force will allow us to do the work easily, and then the moment of force depend on the force applied and the perpendicular distance of the fulcrum to the force. The moment of force depend on the force applied, meaning that if you look at the picture again, depending on how strong the person here exert the force or hold the wrench here to to turn the object, to turn the boat. Okay, and then the perpendicular distance. What are the perpendicular distance? These are the perpendicular distance from this one, for example, from the pivot over here, from the fulcrum to the effort. So this is what we call by perpendicular distance. Perpendicular distance. Okay, these are the force. These are the force over here. All right. These are the fixed point or the moment of force, and then this is the perpendicular distance. Perpendicular distance in blue. Blue line over here is the perpendicular distance. Right? Okay. Next one. Example of moment of force. Just same lah. Ini sama sajalah macam gambar tadi. The example of moment of force are like using spanner or wrench to tighten a nut and the act of opening the door. Alright, you can see here. Oh, sorry. You can see here. This is the nut. This is the pivot, the fulcrum, and then this is the perpendicular distance, and then these are the force. Okay, what happened when we apply the force? What happened when we apply the force? The object will rotate in a fixed position at the fulcrum. Right? This is not animation lah, but actually it is the same thing. Moment of force, the rotation. The object here is the object, the nut over here is the what we call the rotation of the nut, and then perpendicular distance, and then this is the force. Okay, example B, same example also. We have a pivot over here when you're opening a door, all right, and then we have a distance from the force to the fulcrum, and then you have the force over here, and then the moment of force is when the object is rotate on a fixed position. Moment of force when the object is rotate. Why the object rotate? The object rotate because you apply the force. Because you apply the force, and then the object rotate. That's why we call it moment of force. Right? Okay, next one. Okay, so there is a calculation you need to know in order to calculate the moment of force. So what are the variable or what are the value you need to take into account? Right? So we have here perpendicular distance, and then we have the force here. Okay, when you have the perpendicular distance, usually in meter, and you have the force applied. Force applied is N Newton. Newton. So if you have the two variable or you have two value over here, so you can find the moment of force. So very easy. You just multiply the force over here. Okay. Just multiply the force to the perpendicular distance from the pivot to the force in meter. Very easy. So the moment of force is equal to force times the distance. All right. So what are the unit for the moment of force? The unit is Newton meter. N. Okay. I will change this to N lah. I will change this to N. N is the Newton. So Newton meter is the what we call the moment of force. Okay. Example. Okay. You look at the example over here. Okay. Example number 1. All right. Already give you, please identify the value. The value over here, the distance from the fulcrum to the force is 20 centimeter. And then the force applied to rotate the object is 50 Newton. So according to the formula, force multiply with the perpendicular distance. So what are the force? The force value is 50 Newton. You just times 0.2 meter. Okay. But you need to change or convert the meter, the centimeter to meter. Okay. So 50 times 0.2 meter is, so the moment of force here is 10 Newton meter. 10 Newton meter. Please convert first, convert the value first, and then you do the calculation. All right? Is it okay? What are the times right now? Can class? Okay?
Yes.
Now it's 12:31. Oh, I got 3 period today. Can class? This is how you measure the moment of force. Moment of force. Just multiply the force and then the perpendicular distance from the fulcrum to the effort. Okay. Right. So number 2. This is the example number 2. Again, please identify. Please identify the value. Please identify the perpendicular distance here. For example, this is the perpendicular distance, 15 centimeter, and then the force applied is 10 Newton. You just what we call replace only the value. So the moment of force here is 10 Newton multiplied by 0.15 meter. Okay, 15 centimeter. You convert to meter is 0.15 meter. Then you just multiply, then you get the answer 1.5 Newton meter. So the moment of force in this example of question is 1.5 Newton meter. Okay. So next one. Okay. I think right. So I continue. Just a little bit more. Moment of force will increase if the magnitude of the force increase by applying greater force. If you apply greater force, so the moment of force will increase. Or number 2, if you increase the perpendicular distance from pivot to effort, then the moment of force will also increase. Okay, you can see the picture over here. What are the difference between A and B over here? What are the difference? Okay, these are identical spanner, identical wrench, identical wrench here. So what are the difference between A and B? What are the difference? Can anybody spot the difference? Anybody can spot the difference?
The handhold at the different distance.
Can you please repeat? The voice is not very clear, lah. Okay. Or you can type at the message lah. Huh? I don't know, the internet very bad today. All right. Never mind. Okay. I hope you can. Okay. Liao Yin Tong. Yes. Hold at the different distance. Yes. The position. The person hold the spanner. A different position. Right. Okay. You can see here. Meaning that the perpendicular distance from the effort to the fulcrum is different. Okay. At A, the distance is 0.2 meter. And then B, the distance is 0.1 meter. You can see here. You can see here what we call the perpendicular distance. Yeah. This one, B is much shorter. B is much shorter. Okay. And then A is longer. Okay. Without do the calculation, which picture A or B has the highest moment of force? A or B? Which has the highest moment of force, you think? Is it A or B? Or, yes? Okay, never mind. A, right. Okay. Forget that question. Which what we call picture A or picture B can open the or can rotate the nut over here easily? A or B? This is the nut. This is the nut over here. A or B, you can open easily. At A or at B? You A or B class? B,
B.
Sure. A or B? Okay. Again. Right. Okay. You can see over here. All right. Okay. In figure A, the moment of force is 2 Newton meter. And then B is, okay, B, the moment of force is 1 Newton meter. Okay. So, which picture here is easier for you, easier for us to open or to loosen, to tighten or to loose the nut over here? Which one has the easiest? Meaning that you no need to what we call put extra energy. Okay, A or B? Actually, it is A. A, you do not need to put extra energy because the perpendicular distance from the object or from the fulcrum to the effort is longer. If you're using the longer tools, so it is easier for you to open the or to loosen the nut over here. Okay, right. You can see here, because the force applied over here, the force applied is the same. B also the force applied same. Okay, but in A, the moment of force is more. Okay, at B, the moment of force is less. Right? That's why how to equalize the what we call the force over here. how to equalize the both one. Giving it the same distance, all right? A is 0.2 meter, and then B is 0.1 meter. So in order to equal the moment of force, you can change the force you exert in A to how many? How much? Okay. We want to equal it. We want to equal it. All right. If I write 5 Newton, 5 Newton times 0.2 meter is equal to what? Wait, okay. If I change 5 Newton times 0.2 will how much? Ten. 5 Newton times 0.2. 10 Newton. Okay, 4.2 M. Wait, it is just 10 Newton. Okay, it's equal to how many? 1 Newton meter. Okay, same or different? If you use the same pressure, 10 Newton times 0.1 meter equal to 1 Newton meter. This one over here, same or no? Same, equal,
Same.
same. Okay. Which one, A or B, you just need use a little force in order to open the nut over here. Which one? A or B? You just need only little force only. A lah yang tong yes, correct. A, you just need a little force to open the nut. Okay, meaning that because if you use the different distance. Okay, can you understand this? In conclusion, a greater moment of force is produced when the force is applied at a greater distance from the turning point. Okay, from the turning point. The distance, if the greater distance, you have greater moment of force, and then when you have a greater moment of force, you no need to use what we call extra energy, extra force. Just a little energy used to what we call to open the nut or to loosen the nut, just use a little energy. But if the distance is very short, you need more energy or more force or more effort in order to loose or to tight the nut. Okay, can you understand this? For example, okay, can you understand this or no? Can never mind. Later we try to do the exercise and then to test whether you understand or not the question about moment of force. Yeah. Okay, last. This one I hope you already understand this. Very easy, this one. This is the principle of moment of level. Okay, and then I think you already do the exercise on page 107 in your workbook, right? You just remember the what we call the formula over here. Load minus distance load from Fulcrum is equal to effort multiplied by distance of effort from Fulcrum. if you want to balance it, so the distance of effort and then distance of load, if the distance is equal, so you have what we call an equilibrium. It will be balanced. Okay, so just apply the what we call the value over here. For example, this is the what we call example of the question, right? So remember the value. Okay, we have two value over here. Jia-Yin 200 Newton and Wei Hong 300 Newton, the weight of the ball angle over here. All right. So what is the balance distance of Jia-Yin from the fulcrum so that the seesaw is balanced? So you just apply the formula. So 200 Newton times D, because you want to find the D, right? Equal to 300 Newton times 2. So you just multiply and then you just change the position, and then the distance of Jia-Yin should be 3 meter in order to balance the level. In order to balance the level, according to the calculation here, all right, the distance of Jia-Yin from the fulcrum should be 3 meter. Then it will be balanced. Okay. What happens if the distance is same? Balance or not balance? If distance same, Jia-Yin distance same. Wei Hong distance also the same. For example, balance or not balance the level? Balance or no? Okay, it is not balanced. Thank you, Yintong. Yeah, Wamanta, it is not, cannot be level. Cannot be balanced. Okay. So by calculating the distance and the weight, the force, you can adjust the distance so that both position will become balanced. Okay. So Jia-Yin has to sit 3 meter away from the fulcrum. 3 meter away from the fulcrum, and then it will be balanced, right? Next one over here. Show a man trying to move a boulder weighing 100 kilogram using a small stone as a fulcrum. Distance between the boulder and the small stone is 0.5 meter, and the distance between the man and the small stone is 2 meter. Okay, calculate the effort required the man to move the boulder. So gravitational force is 10 Newton per kilogram. Okay, never mind. Okay, by using the same principle, using the same formula, you must calculate first. Okay, you must use the value over here in order to calculate the effort required by the man. Okay. For example, right here. Distance from the boulder to the small stone. This one. Distance here to here, how many? 0.5 meter. And then distance man to the small stone, this one is 2 meter. Okay. And then what is the weight of the boulder here is 100 kilogram. This is the weight of the stone. 100 kilogram, you must turn to Newton. So how many Newton? Equal to how many Newton? I also forgot. 10 Newton equal to 1 kilogram. Okay, how many Newton? 1,000. Because in calculation, you must need to use Newton, right? So kilogram, you must convert the unit of kilogram to Newton. So then 1,000 Newton. You have all this information, and then you can what we call substitute it into your formula over here. Okay, so this is the answer. 1,000 Newton times 0.5, and then the effort times 2 meter. Okay, so what are the answer? You just do the calculation. Yeah, you just what we call substitute the value, and then you get the answer 250 Newton. So the effort this man need to exert is 250 Newton, or equal to how many kilogram? 250 Newton, or how many kilogram? 250 Newton equal to how many kilogram, class? How many kilogram? Berapa kilogram? Ingatkah? 10 Newton equal to 1 kilogram. So 250 Newton, you just divided by 10 is how many? 25 kilogram of, yes, Yolinton, thank you, 25 kilogram of force. Okay, so is it easier for the man to remove the big stone over there? You remember, this is what we call by lever, to easier the work. To let the work we do is easier. The stone is about 100 kilogram. The weight of the stone is 100 kilogram. If we do not use the lever, we cannot move the stone. That's why we need to use the lever. Lever is the simple machine. Okay. When you use the tool correctly, you just need 225 kilogram only to remove 100 kilogram of what? Of stone. Okay. So what is the, if you want to lower, okay, my question is, if you want to lower 25 kilogram, maybe is got heavy also lah, yeah. The man over here, 225 kilogram is heavy lah. How do you suggest, what is your suggestion if you want to lower the value of effort here? What can you do? How to lower the value of effort? What can you do? Anybody? You got any idea how to lower the value of effort? This is effort, This is effort. How? You use what? What can you use? You still remember the perpendicular distance? Meaning that if you use longer lever, moment of force will be increased. So the work will be less. Okay. Maybe you can change the position, or yes, Jiahui, you can decrease the distance. Distance from where? No, you can increase the distance, or you can change the longer lever. Okay. You change the longer lever so that it become 3 meter. Okay, when, must remember, if the distance from the fulcrum to effort is longer, so the effort will be less. Why the effort will be less? Because the moment of force is greater. So you change, you just change into the longer pole, so that the effort is much what we call less. Right? Never mind. Okay. Any question? You have any question? You can ask me later on. Yeah, I think I will stop here. Now is 12:52 in the afternoon. So do you have any question? You can ask me later lah. Yeah. Okay. Where is it? Okay. Okay, so we will stop here. So we will meet again on tomorrow. Yeah, tomorrow we have class. I think tomorrow we just discuss the workbook question. The workbook exercise only. For tomorrow. So tomorrow we start at 11 in the morning. Okay, class. Tomorrow we start at 11 a.m. Okay, if you have any question, you can ask me. I will give you the exercise on your workbook after the class. All right? Okay? Okay. All right. Okay. If no question, right, thank you very much for your participation for today and focus. See you all again tomorrow at 11 in the morning. You can leave the class right now. Bye-bye.
Thank you, teacher.
Thank you.
teacher.
Thank
Thank
you.
you, teacher.
Thank you very much.
Bye-bye.
Bye.